Okay. I had an email to cover numbers 7 through 14 on Math Lab today. I'm just confirming that those were the right numbers. Yes, 7 through 14. So I'm going to start at number 7 and work through. So number 7, when we've got a 45 there in the one of the angles, we know that this is one of those special triangles that's a 45, 45, 90. And that was originally on your 9.1 notes where we had some specific, like you knew that they were going to be certain sides always on these. Like the measurements were like this always same specific ratio or pattern. And that's where the legs are going to be equivalent. It's like one leg was actually that on the paper, it was X. And then the second leg was X. And then the hypotenuse of a 45, 45, 90 angle is X times the square root of 2. So if one of the legs is 5, then the other leg is going to be 5. So in this particular one, X equals 5, and the Y is going to be where you replace the X with the 5 times root 2. So that's all you do for that one. On number 8, it's a 30, 60, 90 triangle, and it also had a very specific ratio. And that was the short leg, which the short leg is going to be opposite the 30-degree angle. So this is the short leg, this is the long leg, and this is the hypotenuse. And the short leg on the notes page was actually equal to X. So it's a blessing. It is actually equal to X here. The long leg is X times root 3, and the hypotenuse for a 30, 60, 90 triangle is 2x. So if x times root 3 is 3 times root 3, then we know x is going to be 3, and we know that the hypotenuse is going to be 2 times 3, or 6 for this particular one. So y equals 6. X equals 3 for number 8. Number 9 is also a 30, 60, 90 triangle. And the short leg is opposite the 30-degree angle. And the long leg is opposite the 60-degree angle. And 8 is the hypotenuse. And what we know of a 30, 60 triangle, 30, 60, 90 triangle is the short leg is X. The long leg is X times root 3. And the hypotenuse is 2x. So if 2x equals 8, then x equals 4. So wherever that short leg is, which we know it's going to be the y in this case. So y equals 4. And so the long leg is going to be x in this case, and it's going to be equal to 4 times root 3. So x equals 4 times root 3 and y equals 4. On numbers 10, 11, and 12, we're supposed to use the diagram and the given measurements to solve the entire triangle. So for number 10, we have B right here as 35 degrees. So B is 35 degrees. C is obviously 90 degrees. So that's a no-brainer because of the big square there. So 90 and 35, that's 125. So the difference between the two is what A is going to be. So 180 minus 125. So A is 55 degrees because all three angles of a triangle have to add up to be 180 degrees. So we also know that the measurement for C is 10. So what we want to do, that's the hypotenuse. So we want to find one of the, angles. So we'll just do sine 35 degrees equals opposite over hypotenuse. So to solve for B, I'm going to multiply 10 to both sides. And so then you plug into your calculator 10 times, and you can 10 times sine 35 equals 5.74. So then you will do a squared plus 5.74 squared equals 10 squared. So a squared plus 5.74 squared equals 32.95 equals 100. And then a squared equals 67.05. And you'll take the square root of both sides. And that's going to be 8.19. So angle A is 55 degrees. Side A is 8.19. And side B is 5.74 for number 10. And that's all of the work for that one. And I have to erase it to move on to number 11 because I'm going to use the same diagram. So but that's essentially what you're going to do for each one of these is just use the information that's given and the diagram to walk you through getting the other side measurements and the angle measurements. Number 11, we're given B again, but this time it's a 48-degree angle. We're also given the measurement of A, which is 8. So in order to find the angle measurement of A, we'll take 90, or angle C, which is 90, and add 48 to it, which gives us 138, and subtract 180. I'll take 138 from 180. And so that tells us that A is 42 degrees. So now we'll have opposite over hypotenuse, which is sine, or we could even do cosine and use B if we wanted to, and do adjacent over hypotenuse. So either way you wanted to think of it would be fine, as long as you're using the right trigonometric function. We'll stick with sine 42 degrees equals opposite, which is 8, over hypotenuse. And if you remember, when we have our variable in the denominator, we proved in class and once on Math Lab algebraically how basically all you have to do is swap places with sine 42 and the variable. Because if you multiply both sides by C and then divide by sine 42 to isolate C, you basically have just ended up switching places. So that's what we're going to do right now. So we'll have C equals 8 over sine 42 degrees. So you plug that into your calculator. 8 divided by sine 42 equals, so C equals 11.96. And now we'll take that measurement, and we've got A, so we've got little c equals 11.96. 8 squared plus B squared equals 11.96 squared. So 64 plus B squared equals 11.96 squared. So that's 143.04. Subtract 64 from both sides, and we have B squared equals 79.04. And you take the square root of that, and you have B equals 8.89. So those are your measurements for number 11. A equals 42 degrees. Little c, or side c, or hypotenuse, is 11.96. And B is 8.89. So number 12, the measurements are big A, or angle A, is 52 degrees. So we need to find the measurement of angle B. So 52 and 90, 142. Subtract 180 minus 142. So angle B is 38 degrees. For number 12. And now we'll take this given information and mix it with we have a measurement of 7 for this side over here. So we could stick with cosine, or we could stick with sine and take opposite over hypotenuse again, or we could use cosine and do adjacent, cosine 52, and do adjacent over hypotenuse. So once again, we can do our little shortcut and just swap places with the variable and the trigonometric function. So we've got 7 divided by cosine 52, and we get 11.37 for the hypotenuse. So now we'll plug in a squared plus 7 squared equals 11.37 squared. So a squared plus 49 equals 11.37 squared. And that's 129.28. Then we'll subtract 49 from both sides. We get a squared equals 80.28. Take the square root of both sides. It's a lot of calculator work. 8.96 for A. So C would equal 11.37 and A is 8.96. So that was number 12. And number 13 is an angle of elevation problem. I think these came from 9.2 notes. .1 or 9.2 notes that we had in class. And we'll see what we're given here. A flagpole projects a shadow on the ground that is 26 feet long. The angle of elevation is 30 degrees. What is the approximate height of the flagpole? So we're given an adjacent side measurement, and we're looking for an opposite side measurement. So the trigonometric function that has opposite and adjacent in it is tangent. So we're going to work with tangent. So tan 30 degrees equals, and then you'll have tangent is opposite over adjacent. So we're looking for the opposite side. So we're going to multiply both sides by 26 to isolate the side that we're looking for. We'll just make opposite be x. And now we'll do 26 times tan 30 equals about 15 feet. And then number 14, a hiker stands X feet from the base of a 24-foot tall tree. The angle of elevation to the top of the tree is 45 degrees. How far is the hiker from the base? So you're looking for this measurement right here. So once again, we have an adjacent side and we have an opposite side. And the trigonometric function that deals with both adjacent and opposite is once again tangent. So we're looking for tan 45. There's also another way that you could do this as well, because if you're thinking about this, tan 45, this is a 45, 45, 90 degree angle. And if you remember, a 45, 45, 90 degree angle, the leg measurements should be the same thing. But I can go ahead and just walk through all of the steps. So really X is going to be 24, should be about 24 once we work the whole thing out. But that's the good thing about 45, 45, 90 degree angles. And oftentimes on the ACT and SAT, you'll have these types of triangles. So if you're looking for legs, the leg measurements are the same on these angles. But let's just see if we can prove that theory. So we'll have opposite over adjacent. So that's opposite over, and here we're using X for adjacent. And remember, we just swap places with our trigonometric function and our variable when the variable is in the denominator. So if you plug that into your calculator, 24 divided by tan 45 equals 24. So we proved our theory. All right, and that completes Math Lab for today. You guys email me or Miss Wynn if you have any questions. Have a blessed afternoon.